All right, we are on example 8 in the principle of mathematical induction packet. I would take a few minutes and try it on your own. Pause the video now, see how far you get, and then once you get stuck, come back and then finish watching this video. For example 8, we are proving by induction that sine of x plus 180 times some number equals -1 to the n power times sine of x. Again, we're proving this for all positive integers. So step 1 is just like before. I have to show that this is true for the first case. So I'm subbing in a 1, right? It's my lowest number. Subbing in a 1 for my n's, right? 1 times 180 is there. -1 to the 1 power is there. -1 to the 1 power is just -1, so that's a -1 times sine, which is negative sine x. That doesn't change on the right. On the left side, I've got a sum in here. You have to think back to the trig unit that we did. The sine of something plus something else, I have to break it apart, whether you knew the cheer or you memorized some other way or you just memorized the formula. That's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. And then I can do some simplifying. If you think back to your unit circle, cosine of 180 is -1. The sine of 180 is 0. 0 times cosine goes away, so I just have sine of x times -1, which is negative sine x. So my left and the right side are both negative sine x equals negative sine x. Check. Step 1 is done. Step 2, my assumption step. I assume that my statement is true for all k's, k positive integers. Again, just change all of my n's to k's. So that one right there changes, that one right there changes. Note, the x's don't change. X's were not n's, so they don't change, right? My n's change to k's, the x's stay the same, right? Assumption step is done. Then for my step 3, here I'm going to change all of my k's to k plus 1s, and then hopefully I can simplify until I show that it definitely must be true. So my original k's there is a k plus 1. My original k here is a k plus 1. Now I basically have a proof. Do you remember doing proofs long ago? So I'm going to pick one of the sides and change it until it looks like the other side. Right? My right side looks a lot simpler, so I'm going to take my left side, the more complicated side, and change it until it looks like the right-hand side. First, 180 distributed into my k plus 1 gives me 180k plus 180, still inside my parentheses with my plus x. So I've got the sign of these three things added together. Okay, I'm going to use that same strategy that I used before with the sign of a sum. I'm going to group my x and my 180k, my x plus 180k together as my first thing and leave this other 180 on its own as my second thing, right? So sine of the first times cosine of the second plus cosine of the first times sine of the second. The reason why I grouped these first two together and left the 180 on its own is because now once I break those apart using the sine of a sum formula, I can do the cosine of 180 and the sine of 180, and those parts will simplify out, and then my variables will be left together, and I can work with those in a minute. Okay, cosine of 180 is, that's right, hopefully you said -1, right? It's on the far left of the unit circle, right? So that's going to be negative of the sine of all of that. The sine of 180 is, hope you said 0. Yes, 0 times this just dies and goes away. Great, so I'm left with the negative sign of this, and all that part disappeared. So negative sign of x plus 180k. Notice what I have here in this step is the same thing that I had up there in my assumption step, right? The sign of x plus 180k. So I can replace that with -1 to the k power times sine of x. Notice this negative here still hangs out front. I'm just replacing the sign, positive sign, of all of that, right? To be -1 to the k times sine of x, right? Negative times a -1 to the k power is basically multiplying by one extra base. So that's the same as -1 to the k plus 1 power, right? Times my sign. So here now I have the left side does equal what the right side originally was, so I can replace my k plus 1s with n's. If n equals k and n equals k plus 1, then by the principle of mathematical induction, my statement is true for all positive integers n.